1948, the magnetic North Pole was in the southwest corner of Prince of Wales Island up in Canada. Now it's moved over about 118 degrees, and they expect it to be in Siberia somewhere along February of 2005.
You mean it moved to the left?
It's moving, yes.
It moved to the west.
It's moved more to the west, and it should reach, they expect it to leave Canada and be in Siberia, somewhere around February. That it's just kind of picked up legs and really have moved. You can
That
see
is awfully fast.
Yes, you can see where they noted it at different times.
That belongs right in this class. Do you have anything off the internet on that? On the shift of the north magnetic pole?
Oh, there is a website. I can't find it, but I was just suggesting if you look for magnetic North Pole moving in the last 25 years, you'll come up and there is a map there. But when you look at that, the magnetic North Pole should be opposite the magnetic South Pole, which means that the magnetic equator now would be more at an angle than in alignment with the geographic North Pole and South Pole. And that would move the north magnetic field in a different direction, which would mean that in some cases there would be more south energies than the north energies that we've been used to. I just thought it was appropriate.
Yes, it is. Thank you. That's another very fascinating field of work that's going on by all kinds of regular scientists with geophysics and so on.
Thank you, Dr. Clark.
You're welcome.
I was curious if, when dealing with electromagnetic radiations from light and sound, if you've done any experiments with your little meter reader?
Say that again. I didn't get every word.
With electromagnetic from coming off of like certain lights.
Lights?
Or tone waves oscillating with your little meter reader. When it's dropping.
What kind of waves?
Tone waves.
How
like
do you spell
electromagnetic fields, if you have like Loran Tower going over you, and how your meter drops or goes up. If you've ever done it with certain lights going on your organisms or your DNA specimens. If it fluxes, does light matter?
Yes, it does matter.
Because?
Yes, it does matter.
I live in a town that has a leukemia cluster.
It's so difficult to discuss and yet so fascinating that you need to, that I wrote down the bits very, very clearly in here so that you can repeat them.
Okay.
You'll find something on light. And light may be the whole clue to this magnetic phenomenon too. So that's a very important part of the whole picture. It's just so difficult to discuss that we need to do it carefully. And that way we'll make more progress by writing down what we observe very carefully. Yes?
I've got a question that's both practical and theoretical. You mentioned that when you first see the rays of the sun in the morning that your polarization shifts. And I'm just wondering, if you don't see it, if you are inside a building, does it still happen? If it is sunny outside, but you don't see the light, you're working in a cubicle inside a building, would you still be able to do the testing?
I would like to do that experiment very much, but I never could find what's called a mu metal that did a good job. I can't find any metal that really keeps out the magnetic field.
Okay, I was asking more about the light. You say on a sunny day that when you see the first rays that your polarization
shifts. In other words, you stay in total darkness. Well, yes, I did those experiments by keeping my eyes absolutely unseeing anything. And I don't remember the results that well. I think they were so hard to do that I was scribbling and not writing on a piece of paper all the time. It was so dark. And then the next morning, I would write a conclusion of some kind. But I did this about 3 years ago. Did a whole bunch of these, and they were very interesting. Your right eye does different things than your left eye does. Your right eye's response to light is different than the left eye's. And the right eye responds to red, and the left eye responds to blue. So you see how hairy it gets when you're studying a phenomenon. and finding that one eye behaves different, and the wavelength of light matters, the color.
What about on a cloudy day? Did the shift happen eventually or not at all?
Not at all.
So we're doomed in BC then, in the winter.
Well, there might be something like that. I think you need to hurry and do some research, maybe with the borealis and other things that you have up there, to see if you're getting something in another way.
Okay, one other thing. What about just calling this biopolarization as a name? To sort of identify a little more.
Biopolarization, that's an idea. I'll write that down. Okay. Is it used in some other connection, biopolarization?
No.
Thanks.
On the same vein as the moving of the north magnetic pole, are you aware of the research that's been done recently in the dropping of the total magnetic field and the rise in the Schumann resonance?
Yes.
Okay.
Can't say much more.
Okay.
Since I don't know much.
You haven't.
But I have. Yes, go ahead.
Done any experiments as far as over a period of time to see what the effect of the dropping of the magnetic field is doing?
No, I haven't done that. But I have been studying the field called electromagnetics, which is sort of a newer offshoot or development from electronics. It just goes into the higher frequencies and how they behave on surfaces. In other words, when you have a radiation that's traveling along the surface of the Earth, you will get vertical lines of force as well as horizontal ones, and that could be important in overall what's happening.
Almost like what you're talking about, similar kind of thing as skin effect with microwave.
Yes.
Okay. Another thing I wanted to mention quickly is that you're familiar with the plate kinesiology and meridians and
Plate what?
Meridians, the 12 meridians in your body.
Yes.
And how each meridian is affected by the time shift in a 24-hour clock.
I have been working with the meridians probably because my skin wears out. I have to do so many experiments in a day after day, that if I stick to a certain point, I'd be losing my fingers. So I'm using the oscillator kind of experiment, where it doesn't matter very much. It matters a little, but not very much, where you're testing, and so I lose sight of the meridians, and I'm sorry about that. I wish I didn't.
Okay, thank you.
Thank you, Dr. Clark, so much for all of your hard work over the years and all the pain and agony that you went through. We do deeply thank you for it. But I got a kind of an interesting situation that a few years ago we studied into geopathic stress, and we found out really interesting through this bizarre study into it that a dog and a cat will never go sleep, or excuse me, a dog will never go sleep with a cat, but a cat will go sleep with the dog.
You mean fall asleep?
Because of the geopathic stress, wherever it goes across, the cat will always go up and curl up into that geopathic stress area, but the dog won't go into it.
How interesting.
It's kind of interesting. Thank you very much.
You're welcome. Thank you for being interested. So don't forget that you're going to cheer me up about
Dr. Clark,
my.
how do you
Yes.
keep your strength?
Well, you give it to me.